This video is our investigation on variation. And you did some variation problems in Algebra 1, but we're going to build on that in Algebra 2. So starting out with direct variation. You did this in Algebra 1 and also in middle school. A linear equation of the form y equals kx, where k is not equal to 0, is called direct variation. The variable y varies directly with the variable x. In other words, the variables change at the same rate. If the value of one variable doubles, the value of the other variable doubles. If one value triples, the other variable triples. The graph over here is a line that passes through the origin. It's a straight line, and the slope of this graph is called k, where k is the constant of variation or the rate of change, how they vary to each other. In middle school, when you did variation, you often used proportions, but in Algebra 2, we're going to use that equation, y equals kx, because we're not going to do simple variation. We're going to get a little more complicated than we can solved with a direct proportion. All right, so let's look at an example. Here's example 1. The number of bricks laid varies directly with the amount of time spent. So if we wanted to write that, the number of bricks laid, we're going to call that B. B equals the number of bricks. So we would start out writing a variation equation with B. When you see that varies directly is when we write equals K for our y equals Kx. And then finally, with the amount of time spent, so it says to call T the time spent, so our variation equation is B equals KT. If that's all they ask you for, you can stop there. But oftentimes they give us more information. So in this one, they say that 45 bricks are laid in 65 minutes. You're supposed to determine K, the constant of variation, and then find the equation that represents the situation. Then they sometimes will give you a new situation where it says, determine the time it would take to lay 500 bricks. All right, so let's look at what we know. They told us that 45 bricks were laid, so that means I can plug in 45 for B in my equation. I'm trying to determine K, so I can't fill anything in for K because I don't know what that is. They told us it takes 65 minutes, so I'm going to plug in 65 for T. Then I have 45 equals K times 65. I would divide both sides by 65 to move that over. And I'd have K is 45 over 65, which reduces to 9/13. If I wanted to rewrite my equation, I would just take this K and I would plug it back into the original formula, and I wind up with B equals 9/13 times T. All right, now let's go back to that new situation they gave us. Determine the time it would take to lay 500 bricks. So in this one, we know B is 500, so I'm going to plug in 500 for B, and then to solve for T, I would multiply by 13 over 9 to 500, which gives me T is 6,509 minutes. You could also turn that into a decimal. We just usually leave it as a fraction though. You should be able to do these without a calculator, but because the math sometimes gets bigger multiplications, we'll let you use a calculator on it. All right, so that's direct variation. That's Algebra 1. Moving to Algebra 2, our new topic is called joint variation. Joint variation. There are situations when more than one variable is involved in a direct variation problem. In these cases, the problem is called joint variation. The equation remains the same, except that additional variables are included in the product. For example, if A varies jointly with the values of B and H, then the equation will be A equals K times B times H. So instead of just having y equals kx like we did for direct, there might be another variable that's thrown on the end there, and all of these things on the right side are still multiplied. So they're both still directly proportional. All right, let's look at an example of this. In example 2, it says, the interest earned I. So if we were writing an equation, I would start with an I. Then they say varies. Whenever you see the word varies and you're writing an equation, that means equals k. Now they tell us it's jointly. Jointly is what tells us everything that follows is going to be direct. So we have the principal p and the time t, so both of those are over here on the right side of the equation, and they're all multiplied together. All right, what else did they tell us? They tell us that we invest $5,000 of principal is invested for 3 years, then $1,200 of interest is earned. And we're supposed to find out how much interest is earned in a new situation when $7,500 is invested in the same account for 4 years. So we start out with the general equation. Again, it was joint variation, so everything was just all multiplied together. Then we need to figure out what k would be by using the information they gave us. They told us that the principal was 5,000, so I plugged in 5,000 for p up here. Then they told us it was invested for 3 years, so I plugged in 3 for t, also on the right. They told us $1,200 in interest was earned. That was I that was over there on the left. I plug in $1,200. My only letter left is k. So I would have my 1,200. I would divide the 5,000 to move that over to the left. And I would also divide the 3 over to move that to the left. And when I put this into my calculator to simplify, I get k is equal to 0.08. I don't want to round any numbers for k. I always want to keep the entire decimal or fraction. All right, so that's my k. They asked me, they didn't ask me to write the equation, but if I did want to rewrite this equation, I would have I equals, I have my k that I just got, which was 0.08, and then that would be times p and times t. So if they asked us for an equation or a model, that would be our model. But what we need to know is how much interest is earned when $7,500 is invested. So that means my principal over here in the equation is $7,500, so I plug that in. And it goes in for 4 years, so I plug that in for the t in my equation. And I can just put this straight into my calculator. 0.08 times 7,500 times 4, and the answer I get is 2,400. So that was the interest. I want to give units with all my real life answers. Those were dollars, and $2,400 in interest is earned. Oops, same page. All right, so here's an example I want you guys to try. It says the number of gallons G in a circular swimming pool varies jointly with the square of the radius. So we're going to need to square our radius and the depth of the pool. And then they tell us it's a 2 feet deep pool, 4 foot radius, needs 754 gallons of water. Find the number of gallons in the pool when R equals 3 feet and D equals 1.5 feet. Go ahead and pause the video while you try to write this variation equation, solve the problem, and give answers with units. All right, so the number of gallons, here's my equation, varies directly. I write equals k with the radius squared, r squared, and the depth, d. I plug in for my known values, and then I solve for k, which gives me 23.5625. Then I rewrite my equation, my original equation from over here, except for this time I'm going to plug in for k. When I plug in my k, then I also know that in my new pool, the radius is 3 feet and the depth is 1.5 feet, so I can plug in those two numbers as well, put this all into my calculator, and I get 318.09375 gallons. Another type of variation that you learned in Algebra 1 was inverse variation. In inverse variation, we have an equation of the form y equals k over x. That's our inverse variation, like the rational function that we graphed. We could also move the x, multiply it over to the left, and we could say that xy equals k. It doesn't matter the form we write this equation. K can't be 0. That's called inverse variation. So if we graphed an inverse variation, it would look like this. Remember when we graphed inverse variation, we had asymptotes on the x and y axis. There was actually another little piece down here, but we're typically dealing with real life situations, so we really only look at the first quadrant. Okay, so in this one, as the x variable increases, the y variable decreases. So as one goes up, the other goes down. The reverse is also true, and the graph is a curve that never touches either axis. All right, let's look at example 3. The time it takes to travel a fixed distance varies inversely with the speed traveled. If it takes Pam 40 minutes to bike to the secret fishing spot at 9 miles per hour, what is the equation that represents this situation? And how long will it take if she rides at 12 miles per hour? Okay, the first thing you might notice in this problem is we have times that are in minutes and speeds that are in miles per hour. So I probably would prefer to use one unit of time. So I'm going to use hours. And right here it says, since the units are not the same, first change 40 minutes into hours. If you want to change minutes into hours, the number of minutes over 60 would be what portion of an hour. So 40 minutes is 2/3 of an hour. All right, now let's write our variation equation. So I'm going to have t equal the time and r equals the speed. We're going to call that the rate. We're used to distance equals rate times time, but let's be sure and read what it said in the problem. It said the time it takes. So I'm going to start with time. Travel a fixed distance varies inversely. When I see vary, that means I write equals k. If it says inversely, instead of multiplying on the top, I'm going to divide and put the next thing on the bottom. So the speed traveled, or r, is going to go down here on the bottom. All right, so now we need to figure out what k equals. So it takes Pam 40 minutes, which we just figured was 2/3 of an hour, when she is traveling at 9 miles per hour. And if I just multiply the 9 across to the other side, I wind up with k equals 6, because 2/3 times 9 is 6. So now I can take that 6 and substitute it back into my original equation up here for k, and I have t equals 6 over r. So that's the equation that represents the situation. Now I need to find how long will it take if she rides at 12 miles per hour. So I'm looking for the time when the rate is equal to 12, and I have 6/12 or a half. I want to give units with that, and that was a half an hour. Now, if this were a multiple choice and a half an hour weren't there, instead it might have said 30 minutes. Just be sure you look at what your choices are. If you have the option of writing your own answer, they're both the same thing, so it really doesn't matter. In example 4, the time to complete the project varies inversely with the number of employees. If 3 people can complete the project in 7 days, how long will it take 5 people? This is an inverse variation. The more people who help, the less time it should take. So that's how we can tell that this is inverse. Go ahead and pause the video while you try this one. All right, so we had the time varies. We write equals k. When they say inversely, that means we know the n has to go on the bottom, the number of people. I plugged into my equation for t and n to get a k of 21. That's my constant of variation. I replace my constant of variation in the original equation, and then I solve for my new situation where I had 5 people. 21 divided by 5 is 4.2. You can leave that as 21/5, 4.2, 4 1/5, it's all the same, but this would be days because the original unit in the problem was days. So again, that was really an Algebra 1 problem. You did inverse variation there. Most of our Algebra 2 level problems, what they really are joint variations or extensions and combinations of the previous types of variation. So let's look at example 5. It says, the strength of a rectangular beam varies jointly as the width and the square of the depth. Okay, we're going to start out with just writing the variation equation for this, and then I'll let you guys go back in and fill in the rest of the stuff. The strength of a rectangular beam, let's call that S, varies. When I see varies, I write equals K. Jointly is what tells me that the things that follow are all direct variation. So the width, we'll call that W, and the square of the depth, D squared. So this is our original function. I'll have you pause the video in just a minute to go back and do that one. Let's go ahead and also look at example 6. In example 6, it says the time needed to paint a fence varies directly with the length of the fence and inversely with the number of painters. So this is a combination of both direct and inverse variation. Let's write the original equation. The time, so I'm going to call that T, varies, that tells me I have an equals K. The next one says directly, so that means the length of the fence, let's call that L, is going to be multiplied times K. The next part says inversely, so that tells me my next variable is going to be on the bottom of this variation with the number of painters N. All right. And then you can go ahead and look in example 7 and example 8. You're just trying to write those out. Let's take a look at them. In example 7, it's just given you a sentence and you're supposed to write the model. B, we write B. Varies means equals K. Inversely tells me what comes next is on the bottom. The product, that tells me I'm multiplying two things together, of A and the square of C. So I have B equals K over A times C squared. You could also not put the multiplication dot in the middle, but realize that the A is not squared and the C is. Okay, so that's just writing the model. In example 8, it says use words to describe the variation modeled. So in this one, you're reading the formula and writing down what you have. M, so I'm just going to write M. Whenever I say equals, now generally this said equals K, but in this case my constant is 6. Okay, so I'm going to say M varies. I don't need to do anything with the 6. That's the constant of variation, which I don't usually state in my model. So it varies. Now I have two things multiplied together, so that means it varies jointly as N and the square root of P. And that's it. We're just writing down the model. Okay, go ahead and go back up to the top of this page for example 5 and 6 and pause the video while you solve these two, and then we'll check them in a second. All right, on example 5, we plug in our values into the equation we already wrote and solve for K. Be sure when you're doing this multiplication, it's 3 times 10 squared. Not 30 squared. You have to do order of operations and square the 10 before you multiply by the 3. Then we divide those to the other side. We get K equals 4. Plug 4 back into our original problem and then plug in our new stuff that we learned. We learned the width was 4 when the depth was 6. I multiply all of this together, gives me 576, and my units for strength was pounds per square inch. All right, on example 6, we had our original equation that we had written. We plug in the information we know, and then we solve for K. That gives us K equals 0.075. Then I rewrote my equation with the K plugged in up here, and I plugged in for my new information where I plugged in 505. Typed this into my calculator, I get 7.5 hours. Again, if it were multiple choice, it might not have said 7.5. It might have said 7 hours and 30 minutes, and either one of those is fine. All right, go ahead and get started on your practice.